Okay, last time we met, 30S students, we started working on literally the student class. So we wrote a student class and we made a new student and we had the student talk. The student class was our first example of inheritance. So a student is a person. So the student class, which extends person, picks up or inherits all the properties and methods of that class. In addition to that, we added two new properties. So a student improves on the person class by adding student number and average into their properties. We also added different methods. Study, slack off, and cram were methods that were specific to the student, so specific student actions. We also, with the student class, wrote two constructors. A constructor with no parameters. Does anyone remember what that special type of constructor is called? And I open this question up to everybody. Constructor with no parameters. Default constructor, correct. Then our constructor with parameters, and what's that called? Two methods, same name, different parameters. Overloading. An overloaded constructor here, which takes name, age, etc. Sets them using the keyword this, and using a call to the superconstructor. All right, here's what I want to do now. In our student class, I want to write one more method. Public, void, talk. And pause for a second and think about this method. We already have this method. It's already in the person class, if you think. Look here. In the person class, we already had a method called talk. And since the student class inherits all the methods of the person class, it already inherited this method. So why is it letting me get away with it? And why is there a little yellow light bulb here? All kind of answer the same question. Because what we're about to do is not overload the talk method. We only have one talk method. We're doing something slightly different called overriding the talk method. So I want to show you my slide notes on what I mean by overriding. So method override implies when we have multiple classes, which is what we now do. We've learned that when you have methods with the same name but different parameters, that's called overloading. But now, when we have classes and inheritance happening, we can have a related concept called overriding. This happens when you write a method with the same name as the class's parent superclass. And what happens is it literally calls that method be over top of the other one. In other words, it overrides it. So the parent super method is called, and the method of the child class is called instead of the superclass. So that's what we're doing right here. So I want to show you what I mean by this. Let's put some code inside of the talk method. Let's just say sout my student number is, and then we'll attach to that student number. And my average is, and we'll attach to that our average. So we're outputting this instead. So when a student talks, they say this. My student number is this, and my average is this. Now, I go back to our testing class. We already have one of our students talk. Let's have our student Marty talk. So Marty.talk. And I play this, and you can see here, my student number is 0 and my average is 0. That's the regular student. My student number is 88 and my average is 2.8. That's Marty. So what's happening is this talk method is overriding the other talk method. But we can actually still call the other talk method as well. So let's add one more line to this method, and we have to put it at the top. Super.talk. So what this essentially means is when a student talks, they first talk as the superclass, which is person. So a person talks first, and then a student talks. So now by adding that line in, you'll see now, it says, I am Jane Doe. I am 0 years old, and if you're wondering if I'm a male, the answer is false. My student number is this, my average is this. I am Marty McFly. I am 17 years old, and if you're wondering if I'm male, the answer is true. My student number is this, and my average is this. Actually, let's add one last thing to this talk method. Just to make it look a little bit nicer, I'm going to put a tab character, that's the /t, in front of the my student number, so that when it outputs, it puts a little tab there. So Marty McFly, and there's their student number right there. Okay? So that's what's called method override. You will notice that the light bulb recognizes that. And it asks you to add something called an override annotation, which is what this is. This is basically a comment. It's a different sort of thing for a comment. This little override, it tells the code that this method talk is overriding the other talk method of the person class. But what's nice in NetBeans is it also puts a little icon right here. See this little, looks like a little green target? And actually, if you put your mouse over it, it says, oh, we override a method from person. But similarly, if you go down over to the person class and look at its talk method, there's another little target there. And it says that the talk method here is overridden. So it's showing you that the two classes communicate with one another, and that they have two methods that are the same name, but there's somehow one is overriding the other. That student is overriding person. Okay?
So can you just go back to the main?
Yeah. This one?
Yeah.
Okay, so I'm going to show you in a second the slide notes on this. So everything I've mentioned is in the slide notes as well. You good, Dawson?
Not quite.
All right, so let me show you the slide notes. So as it says here in the notes, this first line here makes a call out to the talk method of the superclass, which in this case is person, and it runs its code. And that little symbol @overrides is suggested by our NetBeans IDE and is essentially another comment. And it is what's called a Java annotation, which is basically some what's called metadata, which is, metadata is a word which means data about data. All right, so here's my example in the slide notes. I made a student, a new student, smelly teenager, 16, is a male, student number 101305, has the student study, slack off, cram, and talk, and you can see the output that would come out of that, okay, if we were running that code. Now, here's my analogy with the video now. So again, think of this like a bank. So here's a bank, and there's a public area to the bank and a private area to the bank. Like these are like vaults at the bank. This is where you can come in and work with tellers. But again, if we relate it to computer science, this section up here is for our properties. This section down here is for our methods. So we know we can make things public or private. All right. Now we have inheritance happening, which means we have kind of a building inside of a building. So the student is the outer building, and the person is the inner building. So now it's a more complex bank, where there are only certain types of employees can get into certain places. So workers can now travel to specific areas of both buildings, right? So someone in the public can go into the public areas but not the private areas, as you can see here, and can even get into the public areas of the inner building. You like that animation? I worked hard on that, you know. And then the private members can go into the private areas and the public areas and the private areas and the private areas in here as well. Oh wait, no they can't. So it depends again on the way the inheritance is set up. So somebody who works for the student building can't necessarily get into the private areas of the person building. So it's all about setting those encapsulation levels to public and private. Now, the other way classes can communicate with each other is through what's called association. This is a simpler relationship. This is called the has-a relationship, as opposed to the is-a relationship that we were just dealing with. So a student is a person, yes. But we're going to build something a little more complex than this. Let's build a teacher class. Now, from this diagram, you can see A teacher is a person, but a teacher has a student. So that's a different relationship there. That's not inheritance. It's not like a teacher is a student. A teacher is a person, but a teacher just has a student. We're also going to make a Husky class. And a Husky is a student, which is a person. So we're going to build a little more complexity into the way our code is set up. And actually, if you look at the diagram below, it shows you even more details. So not only does it show you the interconnectivity of these classes, but I also broke down all the properties and methods. Now, you don't need to examine that in too much detail because we're going to code it right now. We're going to code this little class. Okay, so it's time. Let's make another class. Let's start by making a Husky class. So I want you to right-click, create another new Java class. Okay, so you're right-clicking on the package, new Java class. This class is called the Husky. I thought that was easier to type than Sturgeon Heights student, which is a lot of typing. Okay, so we're creating class Husky. All right. So here's what we know about Husky. Husky extends student. So what that means is a Husky is a student. But a student is a person. Does that mean that a Husky is a person? Have you guys ever heard of transitive property in math? I hope so. It's something as simple as this. X equals 5. Y equals X. Therefore, Y equals 5. By transitive property. This is a concept you should have learned in elementary school. Although now you guys use fancy things like this when you're proving stuff, but you know, transitive property is just a very basic law of logic that the X is transposing itself to Y, and therefore Y holds the same value as X, etc. So that applies here. A student is a person. A Husky is a student, therefore a Husky is also a person. So by just writing that, Husky extends student, let's go to our testing class. And let's make a Husky. Husky equals new Husky. And then Husky dot, and what you'll notice is you get all the methods of the student class. So you can study, you can cram, but you're also getting all the methods of the person class. Birthday, operation, etc. So now you're seeing that the code you write can start compounding upon itself and creating a better sort of system. And when we do this after we do graphics, you'll see in maybe a gaming example how you can make objects in your game and then build upon those same objects in your code. So inheritance is a big concept that can really help you with coding down the line. Okay, so there's our Husky class. So since we made a new class, let's add a property. A property that's different than most students. So every student has a student number, and every student has an average. But what do you students in Sturgeon Heights have that other students don't? Pride. Husky pride. They talk about it. Now, what should that data type be? Pride. So it could be a Boolean, as was suggested, which means it's either true or false. You have pride or you don't. But it could also be a number, like between 0 and 1,000,000. It could also be words. Maybe pride is words. So Dawson and Rain, I got to rely on you guys for this. How do you envision Husky pride? Do you see it as true, false? Do you see it as a number? Do you see it as a word? I want to know. They're not even listening, are they? What do you see pride as? Don't influence them. Let them think on their own. They're, we're all waiting. Because I don't know if it's, you think it's a Boolean? What do you think, Rain? When you think of school pride, do you think of it as yes and no? Is it really that simple? You either have school pride or you don't?
Well, it doesn't matter how much school pride you have.
Well, that's what I'm asking, though. If it's an amount, like you can have a little or a lot, maybe it should be words. Maybe it should be a number. Maybe it should be so accurate it should go all the way to doubles. You can have 78.365 amount of pride. I don't know. We'll go with Boolean. That's the easy answer. You guys went with the easy one. Now, the next question is, what am I going to put in front of this? Dawson? Why would I put something in front of this property? What are the two things I could put here is instead of the question mark? It's related to encapsulation. Private and public. That's right, Rain. Private or public will either make it locked inside the class or opened outside the class. I think we should lock it. So I'm going to say let's make this private. Our pride is private. Okay. Now, let's write a constructor. We knew we had to do it anyways. So public husky. And let's not even make a default constructor. Let's start it off with a whole bunch of information, like name, age, etc. So to shorten up my typing, I'm going to go back to the student class and do a little copy paste. So I'm going to take all of this stuff, name, age, etc. I'm going to copy it. I'm going to bring it over to the Husky class, paste it. I am going to take average out. I don't think I need to put average into it. Okay. I'm going to make a call to the super constructor. So here's the name, age, gender, student number, and then for average, I'm just going to give it 0.0 as an average. Okay. So when I build up a Husky, I will first build up a student, and I will use its constructor to build it with this name, this age, this gender, this student number, and an average of 0.0. So I'm just going to say whenever you become a Husky, you start off with an average of, actually no, let's make you guys a little smarter. Let's assume every Husky starts with an average of 1.0. So you just, when you are a Husky, you have a grade point average of 1.0. It's not very good. Maybe we should do it better, right? What should we make it? Should we make it 4? Or is that too, that's too high? You thinking 3? Okay, let's do 3. Now, there is one other property we have to set, pride. Now, here's the question. Do you start with Husky pride when you first become a Husky? You're a liar. You're an absolute liar right there. I remember you kids on the grade 9 first day. I remember you kids before that. The open house when you guys came in here as the little grade 8ers, all wide-eyed and excited to come to Sturgeon as on that open house. I was here, and you guys were touring on that day, and you absolutely had pride when you first started. It's only been the 4 years you've been here that's turned you into jaded monsters that now couldn't care about anything in the world, but I'm going to assume that you absolutely have pride. Pride is true. All right. That's our constructor. So now, you can see here, oh, I can't use this default constructor anymore because in order to build a Husky, I have to feed it the information. I have to feed it the name, age. Okay, so let's feed it the name. The name of our Husky will be Havoc Husky. The age will be 9, almost 10. You know what I mean by that? Does anyone know what that riddle means? 9, almost 10. Is male? No. Let's make it a female. Oh, did you assume that the Husky statue outside was male? You sexist guys out there. No, I'm going to assume it's female. And what should our student number be for? Like, I know, Havoc the Husky. That's what I said. Transgender? Seriously? Holy, you got to take that another. Wow. Havoc, what? How do you know that? How do you know he was a boy?
Havoc is being racist against males. You're being racist against women.
I didn't assume that that Havoc was in fact. Now, by the way, here's what student number I'm going to give. here's the riddle. Why did I make Husky 9 years old, and why did I make that the student number?
The
It-
school was 9 years old and they were on
address is
address 2665.
Almost correct. What do you mean by the school is 9 years old?
School amalgamated 9 years ago.
Correct. Correct. And 2665 is our address on Ness Avenue.
667.
No, 2665 is the address of the school on Ness. It's not when everybody dies. And now husky.talk. Notice we have that method. So let's play what happens to Havoc the Husky. I am Havoc Husky. I am 9 years old. And if you're wondering if I'm a male, the answer is false. My student number is 2665 and my average is 3.0. That's what happens when we build up a Husky. All right. Let's write some specific methods for a Husky. What can a Husky do that other students can't do? Well, I've got a couple. Yes?
My super isn't working.
Okay, just a sec.